These are the Lesson 7.5 notes, day 2 on solving radical equations. What we're going to start with, though, are some equations that don't have radicals in them. We're going to look at some equations that have this exponent of 1/2. You might recall when you're working with an exponent of 1/2, the bottom number is the root and the top number is your exponent. So we're going to be taking values that have a second root or a square root of something to the first power. So whenever you see x to the 1/2 power, it is the same thing as the second root of x to the first, which is another way of just saying square root x. So wherever we see this 1/2 power, if you would rather write it as a square root, you can do that. And that's what we're going to do in this first problem. We're going to change both of these 1/2 powers to square roots. On our second step, it says isolate the square root if necessary. Square root both sides of the equation and solve for x. Well, we have a square root on the left and a square root on the right. We're just going to square both sides of the equation, and whatever you do one side, you have to do the other. A squared side should cancel a square root, so this problem merely becomes 6x minus 4 equals 4x plus 5. Looked tricky at first, but now it's just a simple algebra equation. I think you know how to solve this out here. You can do one of 4 different things here. I like to get rid of the negatives personally, so I'm going to add 4 to both sides. You could do that. That cancels them out on the left side. On the right side, you're going to have a 4x plus 5 plus 4 is 9. Then to get the x's by themselves, we're going to move the 4x to the left side because we have a number 9 by itself on the right. So we'll subtract 4x from both sides, and on the left you have 6x minus 4x, that's 2x. On the right side, the x's cancel and you have a 9, and I think you know at this point you can just divide both sides by 2. And I'm fine with you leaving the answer as 9 over 2. I guess if you want to write as the decimal 4.5, that's fine, but I think it's a little bit easier to write it that way. Here's our second problem. We've got x plus 5 on the left side. On the right side, we have something to the 1/2 power. So kind of like we did before, we're just going to rewrite the right side of this equation as the square root of x squared plus 5. Once you have isolated the square root, which we've kind of done here, we want to get rid of the square root, and we're going to do that by squaring both sides. We'll square both sides of this equation. And on the right side, obviously, the square and the square root will cancel each other out. We'll have x squared plus 5. On the left side of the equation, we have this x plus 5 squared. And you might remember from last week, when we square something, we're multiplying it by itself. So on the left side, we're going to do x plus 5 times x plus 5. On the right side, again, the square root and the square sign cancel out, and it's just x squared plus 5. On the left side, we're going to have to do this FOIL process where everything on the left side gets multiplied by everything on the right side. So we're going to do x times x is x squared. X times positive 5 is 5x. In the middle, 5 times x is also 5x. And on the last part, we do positive 5 times positive 5, which is 25. On the right side of the equation, we still have that x squared plus 5. And now we're just going to try to solve for x. One thing you might have noticed is we do have 5x plus 5x here. You can add those together and get 10x. So I'm going to add these two together. So we have x squared plus, that's 10x, plus 25 equals x squared plus 5. We can subtract x squared from both sides of this equation, and the nice thing about doing that is it's just going to cancel itself on each side. So these x squareds cancel out, and we're left with 10x plus 25 equals 5. This problem looked difficult at the beginning. Now it's looking pretty nice, right? We're going to get x by itself by subtracting both sides by 25. And if it gets to be some problem that you're kind of struggling with, you can always get out your calculator and crunch out 5 minus 25 if you need to. That should be negative 20. So on the left side of the equation, we have 10x. On the right side of the equation, we have negative 20. And then we'll just divide both sides by 10. Again, I would guess most of you probably know what that's equal to, but you can always crunch that out on your calculator if you need to, and you get x equals negative 2. That's your solution here. So far, so good. This last problem's kind of the same thing we started with earlier. We have a 1/2 power here. You can always replace the 1/2 power with a square root. We've done that on each of these first problems, and we're going to do that here as well. So if you're like, ugh, I don't like that 1/2 power, well, change it to a square root. It's a little bit more friendly. Isolate the square root. It's isolated. Square both sides of the equation. Okay. Solve for x. All right, so when we square a square root, square and the square root should cancel out. we're just left with 5 plus x on the left side. And on the right side, we have 3 squared. 3 times 3 is 9. Wow, we're almost done, right? Subtract 5 from each side. 5's cancel. On the right side, you have 9 minus 5. That's 4. So really on this side of the worksheet, not too bad. We changed the 1/2 powers to square roots, and most of these problems can be solved in a matter of a few steps. On the back side, it gets a little bit more challenging. So on the back side of the equation, we are going to be working with a problem with multiple square roots. So the 1/2 power is gone. We have multiple square roots here. And it says what we're going to do in problems like this is we're going to square both sides of the equation, then solve for x. So the first step we're going to do is we're going to square the left side of the equation, and everything on the right side of the equation, we're going to group this together. We're going to square this as well. The left side of the equation is easy. Square root the x squared, we square root of x, we square it, the squared and the squared cancel out, you're just left with x. Unfortunately, on the right side, it's not going to be as easy. When you square something, you're multiplying it by itself. So in this problem, we're going to be taking the square root of x plus 5 minus 1, and we're going to multiply it by itself. The square root of x plus 5 minus 1. On the left side of the equation, we have an x. That's easy. On the right side, it's a little bit more challenging. We're going to multiply the square root of x plus 5 times the square root of x plus 5 first. You'll notice this kind of resembles the FOIL process we've done in the past. So the first thing we have to do is we have to multiply a square root by itself. So just a reminder of how kind of square roots work. If you take the square root of 3 times the square root of 3, that's equal to the square root of 9, which equals 3. If you were to take the square root of 4 times the square root of 4, that's actually equal to the square root of 16. And if you square root that, that's equal to 4. If you take the square root of 10 times the square root of 10, multiply the numbers, you get 100, and the square root of 100 is equal to 10. So anytime you multiply a square root of something by itself, you get kind of the number that's under the square root. So if we use the same logic, if we multiply the square root of something by itself, we should just get x plus 5. That's the first thing you'll get when you multiply these things together. The square root of x plus 5 times the square root of x plus 5 is x plus 5. Let's go to the outside parts here. Negative 1 times the square root of x plus 5. That's going to be negative 1 times the square root of x plus 5. Inside, negative 1 times the square root of x plus 5 again. That's going to be negative 1 times the square root of x plus 5. Last, negative 1 times negative 1. Don't forget, when you multiply a negative times itself, or negative times a negative, you get a positive answer. Negative 1 times negative 1 is positive 1. So there'll be a little plus 1 right here. Let's get this stuff out of here. So we're going to simplify some things on the right side of the equation. On the right side of the equation, we have, well, on the left side we have x. On the right side we have an x. We have a positive 5 and a positive 1. We're going to add the 5 and 1 together. That's 6. We also have a negative 1 root x plus 5 minus another 1 root x plus 5. When you combine this and this, you get negative 2 square root of x plus 5. For the same reason that if you took negative 1x minus 1x, you would get negative 2x. Negative 1 in front of this x plus 5, or square root of x plus 5, minus a 1, same square root of x plus 5, gives you negative 2 square root of x plus 5s. All right, let's solve this equation out. We're going to need to, well, one thing we could do is we could subtract x from each side. That will cancel the x's on the left, so we have nothing on the left side. On the right side, the x is gone, and we have 6 minus 2 root x plus 5. And make sure that x plus 5 is underneath the square root. Similar to what we did with problems like this earlier, we're going to isolate the square root, which means we need to say goodbye to the 6. We're going to subtract the 6 from both sides. When you subtract the 6 from both sides, you get a negative 6 on the left side. On the right side, the 6's cancel, and you have negative 2 root x plus 5. The next thing we're going to say goodbye to is this negative 2. It's being multiplied by the square root, so to cancel it out, we need to divide it on both sides. If you forgot what negative 6 divided by negative 2 is, negative divided by negative is a positive, and that's going to be a 3 on the left side. On the right side, the negative 2's cancel, and we're left with the square root of x plus 5. As to be expected, to cancel out the square root, we're going to square both sides. You might be like, didn't we square both sides earlier? We did. We got to do it one more time here. So we're going to square both sides. This should cancel out our square root. On the left side, 3 times 3 is 9. On the right side, the square sign cancels the square root. We have x plus 5. And finally, one last step, subtract 5 from both sides, and you get x equals 4. We have a similar problem on the right side of this equation. It's going to utilize pretty much the same steps we had before. You should get something pleasant for an answer. You'll try that one out on your own. Otherwise, you've got enough information here to be able to solve these radical equations that have square roots or exponents of 1/2 on them.